In this notebook, we use Dask along with NumPy and CuPy, a GPU NumPy library, to do a parallel GPU and CPU SVD computation. So I'm running on a DGX computer. It has 8 GPUs all tied together. I'm going to create a random data set using NumPy and Dask array. This array is 1 million by 1,000, cut into 10,000 by 1,000 chunks. So every box here, every line up the right corresponds to the activity of one CPU core in this case. And we're creating 100 different NumPy arrays. They each take about 100 milliseconds to be made. I'm now going to call the Dask array SVD algorithm on that. And what that does a blocked SVD computation. Turns out we can compute a tolerance getting SVD, an SVD computation on a tolerance getting matrix by doing lots of QR decompositions of smaller SVD and other operations. We're seeing a task graph of that depicted here in the center. So each little tiny circle at the bottom corresponds to one NumPy array. Then each other circle corresponds to some other blocked linear algebra computation. All I want to show here is that this graph is somewhat complicated, and that Dask is going to handle executing that complex graph for us. So let's go ahead and actually compute that. Previously, we were just lazy, and we'll run it. So it's going to take a little bit of time, and we're going to look at the task graph again. So here's that same graph, but now this is live. And what we're seeing is that we have about 8 QR decompositions that are being crunched on our CPU at the same time. And here they're coming in. They're taking 18 seconds, maybe 17 seconds each. We've got done 8 out of 100. So this is going to take a little while. It's a little bit painful to watch. So we're going to pause. We're going to restart our notebook, and we're going to go ahead with the GPU. So, but again, I want you to sort of notice these are taking 15-ish seconds. So I'm going to restart my notebook. We're going to set up Dask on the DGX again. And now, rather than using NumPy, I'm going to use CuPy. CuPy is a library, comes out of the Chainer project. It implements a large subset of the NumPy library on the GPU. And we're just going to make that change. And so now, rather than creating a Dask array of many NumPy arrays, we're creating a Dask array of many CuPy arrays. It takes a little bit of time to import, but once it's imported, it's quite fast. So that operation we did, the SVD, is exactly the same. There's no code change except for this one change here. We're going to compute that SVD again, but now again, rather than using CPU, we're using 8 GPUs. So each little blue box here, each little green box here, corresponds to one QR decomposition. And now rather than taking 15 seconds, they're taking 300 milliseconds. The algorithm does SVD in the middle, and then does a lot of communication. Red is communication. A lot of communication in order to reconstruct the U matrix at the end. So there we go. Did the whole SVD in about 20 seconds, where previously it took 20 seconds just to do one round of the QR decompositions. The thing we get back is just, again, a set of normal NumPy and Dask arrays. So everything works quite nicely. Okay, again, this is showing you how you can use CuPy along with Dask array to give you parallel and distributed GPU NumPy-like arrays. Thanks for your time.